All right, so I'd like to start with this problem, but I want to give you guys a minute to try it. So let's see if we can get everyone through this problem, give you a minute or so, and then we'll work it together in just a minute. All right, so based on what we were doing yesterday on this problem, we should let u equal x squared. We're going to let dv equal e to the 2x dx. And then if we do that, du is 2x dx. And v is the antiderivative of e to the 2x dx. So it's 1/2 e to the 2x. So the integration by parts formula is that we get uv. So that's 1/2 x squared e to the 2x minus v du. And so if I multiply v times du together, I get 1/2 times 2, which is 1. And then I get x e to the 2x dx. And so if you have a step where that's a little less simplified, take an extra step to get to here. But any questions to that point?
Yeah, I do. So what where'd the 2 and the 2x from du go?
Okay, so when you get that second integral, the formula says that it's the integral of u dv is equal to uv minus the integral of v du.
Oh,
So
it's 1/2 times 2. I'm sorry, I just realized
you're
that.
completely fine. When you multiply v times du, 1/2 times 2 cancels, and then I put the x at the beginning.
Okay, thank you.
Okay. Yeah, no problem. Other questions so far? Okay, so now we're going to do parts again. So I'm going to block this off, and then we're going to set up u and dv again for this new integral. And for the new integral, u is going to be x, and dv is going to be e to the 2x again, dx. So du is 1 dx, and v is the antiderivative of that, so it's 1/2 e to the 2x. So now the 1/2 x squared e to the 2x carries down. And then minus, now uv is 1/2 x e to the 2x minus v du. You pull the 1/2 out, and then you get e to the 2x dx, but all of that's in brackets. So this bracket part, that is the integration by parts formula on this second integral. Okay, you should take a step to distribute the negative. And if there was another coefficient, for sure, take a step to distribute that. Until we get it to there. Now, that last integral is a quick u substitution where u would be 2x. And so we're going to get a 1/2, an additional 1/2 outside. So we're going to get, whoops. Let me turn those off real fast. So, okay, so we're going to get 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. And that's the answer. Okay, any questions on that? Everybody good? Okay, so I want to look at another problem, and then I want to start talking about the different types of setups we could have. So I want to look at the integral of x to the third natural log x dx. And I want to look at two potential setups for this. So if we're going to try parts on this problem, the two obvious setups would be to let u equal x cubed and dv equal natural log x dx. Or we could let u equal natural log x and let dv equal x cubed dx. And there are other setups we can do, and we'll kind of see some later, but those I think are the two most obvious. Does everybody get that? Okay, and so if we do these setups, we have to find du and we have to find v. So in this first setup, du would obviously be 3x squared dx, but why would this not be 1 over x? So why is v not 1 over x in that case? What do you guys think?
This is like the derivative of 1 over x.
Yeah, so the derivative of log is 1 over x. The antiderivative of log is not 1 over x, right? And so somebody's saying that in chat as well. So this is the derivative of log x. Do we know the antiderivative of natural log x? Do we have a formula for that yet? We don't. So we know the derivative of natural log x is 1 over x. We actually don't have this. And so that is not a good setup because we don't know how to do it. And we're going to see why the other one is a good setup. But if we do it down here, if we say u is natural log x, now du is 1 over x dx. And v is 1/4 x to the 4th. Does that make sense to everybody? Now, it's not obvious that that's going to work yet, but when we start working it out, if we use that setup, we get uv. Well, uv is 1/4 x to the 4th natural log x. And then I'm going to write this without simplifying and then take an extra step. But if I put v du, I get this inside that second integral. Why is that actually good? What can I do with that? You can say it out loud or put it in the chat, either way. But what do you guys,
You could pull the 1/4 out and then
Okay.
turn the 1 over x into x to the -1 and combine them.
Yeah, so if I combine them, it would be what once I do that?
X to the third.
X to the third, yeah. So x to the 4th times 1 over x, you can simplify that a couple ways. You can make it x to the 4th over x, which is x to the 3rd, or you can bring it up, make it x to the -1, and then add the exponents. And either way, you get x to the 3rd. But does everybody see why we get what we get there? And now, why is that going to work? Why is that going to work? So what do we now do you guys think?
We know what the derivative of antiderivative of x to the 3rd is.
Yeah, we know what the antiderivative of x to the 3rd is. We know it's 1/4 x to the 4th. So we get another 1/4 in there. So you get 1/4 x to the 4th log x minus 1/4 times 1/4, so 1/16 x to the 4th plus c. But now we're done. Does everybody follow that? What we're doing there? Everybody good? Okay, so what happens as far as these setups is when you go from u to du, you take the derivative. Does that make sense? Okay, so you take the derivative when you go from u to du, and when you go from dv to v, you take the antiderivative. All right, so when you're using integration by parts, what you're concerned with is this new integral v du. The uv, that is part of the answer, and like you need that. But as far as working the problem, you are done with that at that stage. So you don't need to worry about how complicated u times v is, because you don't have to do anything with it. What you do need to worry about is v times du. You need this problem to be something we can handle. So like what's going to happen is whatever you start with, you take whatever u is, you're going to take its derivative to get this part. And whatever dv is, you're going to take the antiderivative to get this part. So if you're looking at this problem without writing all this out, x cubed, if you take the derivative, it's going to drop a power. It's going to become x squared. If you take the antiderivative, it's going to go up a power. It's going to become x to the fourth. The coefficients are going to factor out anyway, so you don't have to worry about those when you're thinking of how to set up the problem. So what we're trying to do is determine what setup is better to begin with. So you think, okay, well, if I let u equal this, it's going to drop a power to go to here. If I let dv equal this, it's going to go up a power. Does that make sense? Okay, now log, if I take the derivative, it's going to become 1 over x. So if I go from u to du, this will become 1 over x. If I take the antiderivative, I actually don't know how to do that easily. And so then that's probably a bad call, which is why this is the only thing worth trying at this stage. But now let's go back up and think about that on the first problem. Does everybody get what I'm talking about? Okay, so we're trying to think through how do you know what to set up here? How do you know what to pick for u? And how do you know what to pick for dv? And there's not like an easy answer to that, but this is a good way to think about it. So like on this one, if you have x squared, if you think, okay, that could either be u or that could be dv. If it's u, it's going to drop a power. It's going to go from x squared to x to the first. If it's dv, it's going to go up a power. So x cubed will become, or x squared will become 1/3 x cubed. And so you think, okay, well, I'm either going to drop from x squared to x to get to this, or I'm going to go from x squared to x cubed to get to this. Now, for e to the 2x, if I let u equal e to the 2x, what's the derivative of e to the 2x? So if I let u equal this, what's du going to be? What do you guys think? What's the derivative of e to the 2x?
2e to the 2x.
Yeah, 2e to the 2x. The 2 is going to factor out anyway. But if I take the derivative, e to the 2x is going to be in there. Also, if I take the antiderivative, e to the 2x is going to be there because the antiderivative is 1/2 e to the 2x. So no matter what, e to the 2x is going to be in this new integral. And so the thought process should be, okay, would I rather drop a power or would I rather go up a power when I go from here to here? Does that make sense to everybody? So if I'm going to keep e to the 2x, what you want to think, okay, would I rather go from x squared to x or would I rather go from x squared to x cubed? If I drop a power, by doing it one more time, the x is going to drop out completely and I'm going to be able to do the problem. Everybody clear on that? Any questions on that? Okay, so then if I look at this next problem, let's do x. I think we did one similar to this yesterday, but let's talk about it anyway. Let's go through this anyway, because I want to talk about how we knew to set it up the way that we set it up. So on this problem, if we think about the two possible setups, if you let u equal x squared, then du is going to become x to the first. And so let me write the formula up here again real quick. So we got u dv is uv minus v du. So you go from u to du, which means we're going to take the derivative. So we can either go from x squared and drop down to x to the first, Or if we let dv equal this, we're going to go from x squared to x cubed. Does that make sense to everybody? Everybody clear? Okay, so we can either go from x squared to x or from x squared to x cubed. When you do cosine, if u is cosine, what's the derivative of cosine? Or what's the derivative of cosine 3x? -3 sine 3x. And so the coefficient's going to come out anyway. But if you take the derivative of this, if this is u, you're going to get sine 3x over here. If you take the antiderivative, you're also going to get sine of 3x over here. Does that make sense to everybody? So no matter what, you're going to go from cosine 3x to sine 3x in this new integral. So would you rather go from x squared to x, or would you rather go from x squared to x cubed when we do that? So we'd rather go from x squared to x because it's going to drop down a power. You're going to get x sine of 3x here. And then if you do parts again, you can drop the x off and you're going to get back to cosine and you'll be able to do the problem. I don't want to work this one out completely because we did do one a lot like this yesterday, but does everybody get that thought process? Everybody get that idea? Okay, I'm going to take that as a yes. Don't see anyone saying no. But okay, let's look at this problem and let's actually work this problem out completely. So if we have that, then the two basic setups, it's weird because there's no real multiplication here. You've got log x times dx, but everybody remember this is not like log times x. X is inside of log, like it would be inside of sine or cosine or square root or something. So the two possible setups here would be to let u equal the whole thing and let dv equal dx, or to let u equal 1 and let dv equal the whole thing. And both of those are a little bit weird, but you can do that. You can say, okay, well, one of them is basically just 1 and the other one's the whole thing. And same thing here. Here u is 1 and dv is basically the whole thing. Dx is pretty much always going to be in dv. But other than that, you could set it up these ways. So if you do this first setup, that works fairly well because I know how to do du. Du is 1 over x dx in that case. And then v is the antiderivative of 1 dx. And so what do we think? What would be v in this case? If dv is just 1 dx, what would v equal?
X.
X, good. So antiderivative of 1 dx is x. Okay, so maybe that will work. But if we do this setup, du is 0, which is weird, but that might be okay. 0 dx or just 0. V, again, the problem is we have to take the antiderivative of that. Does that make sense? If we knew how to do the antiderivative of that, we could probably just do this problem, right? Because that's what we're trying to do anyway. So this is just, okay, that's basically just doing the problem within parts. We don't want to do that. Okay, we don't know how to do this. That's the whole reason we're doing parts to begin with. So this does not work down here. So we're going to go with this first setup. So again, the formula is it's uv minus the integral of v du. So uv is x log x. V times du is then what happens when we do x times 1 over x.
1.
Yeah, we get 1. So we get 1 dx. And now we get x natural log x minus x plus c, because the antiderivative of 1 dx is just x. And that's the answer. Does that make sense to everybody? Any questions on that? All right. So what I would like you guys to try is inverse tangent of x. And I want you to keep in mind that 1 over 1 plus x squared is not the answer because that's the derivative of inverse tangent x, not the antiderivative. And so I want you to think about these types of setups where you could let u equal the whole thing or let u equal 1 and see if you can come up with what setup's better. I'm giving you 2 minutes on this one and see if you guys can get an answer, and then we'll check it together in just a minute. Okay, so we're going to start working this together. The setup that works is to let u equal inverse tangent x and let dv equal then 1 dx. du is then the derivative of inverse tangent x, which is 1 over 1 plus x squared dx. And v is the antiderivative of that, which is x. Does everybody follow to there? Everybody good? Okay, so we go with the integration by parts formula, which is uv, so x inverse tangent x minus v du, which is x over 1 plus x squared dx. Now, this isn't quite as straightforward as ones we've done before, but what do you do for this integral? Is this a basic form? Is it u sub? Is it parts? Or do we not know how to do this yet? What do you do on this?
Wouldn't it be a u sub?
Yeah, it's a u sub. So it's a u sub where u is 1 plus x squared, and then du is 2x dx. And so we get x inverse tangent x minus, and now we're going to move the x off the fraction. And you need a 2 here, so we need a 1/2 out here. Now we get x inverse tangent x minus 1/2 integral 1 over u du. And then that's 1/2 log absolute value of u plus c. And then u was, for that part, u was 1 plus x squared. and we get to there. Does that make sense? You can drop the absolute value on that. I think WebAssign doesn't like it, so I'm going to leave those in there. But because 1 plus x squared is positive, you don't need the absolute values on that one. But any questions on how we're doing this? Everybody good? Okay, so these last two problems are examples where it's not really clear that it should be parts to begin with. It's just, it happens to work out that when you set it up this way, you get this integral that we're then able to do. Obviously, the integral of 1 dx is really easy. This one's not quite as easy, but it's not terrible. You can do it with u substitution. Inverse sine is going to work almost exactly the same as this, except you're going to get x over the square root of 1 minus x squared. We're not going to do that together in class. You're going to get to try that on the homework, but please take some time with that and make sure you can get it. And if you can't, then we'll work on it tomorrow, maybe right after class, if we need help with inverse sine. But inverse sine is going to work a lot like this one, but I do want you to try that one on your own. Any questions up until here? Everybody good? Okay. All right, so the next one I want to look at is e to the x sine of 3x dx. And so this is one that actually kind of looks like parts. And so this is one where we do parts. The inverse tangent, I think, doesn't really look like it should be parts, and log doesn't either. But this one does. And there are two basic setups. Again, I'm going to write this formula over here on the side. So the integral of u dv is equal to uv minus the integral of v du. And so we went from we're going to go from u to du, which means we take the derivative of that part, and from dv to v, which means we're going to take the antiderivative of that. So if we have e to the x, if you let u equal e to the x, what's the derivative of that? If you take the derivative of e to the x, we get e to the x. And if you take the antiderivative of e to the x, you also get e to the x. Does that make sense to everybody? So no matter what we set e to the x as, we're going to get an e to the x over here. And then if we talk about sine of 3x, if you take the derivative of sine, you get cosine. And then if you take the derivative again, you get sine. If you take the antiderivative of sine, you get cosine. And if you take the antiderivative again, you get sine. So no matter what, here you're going to cycle sine, cosine, sine, cosine. And so something weird happens here. But the thing is, it doesn't really matter what you choose for u and what you choose for dv. So I'm going to choose it so that we get 3 rather than 1/3 by doing this. So I'm going to set it up where we choose for u to equal sine 3x. But the only reason I'm choosing that is because now when I take the derivative and use the chain rule, I'm going to get a 3. If I were taking the antiderivative, I'd get a 1/3. I'd rather deal with 3 than 1/3. And so we're going to set it up that way. But you could also set this up the other way. Does that make sense? Okay, so du is the derivative of that, which is positive 3 cosine of 3x dx. And v is the antiderivative of dv, which is then just e to the x. And so we're going to set this up as uv. So uv is e to the x sine 3x minus v du. And so we're going to factor out the 3 and get e to the x cosine of 3x dx at that stage. And I'm going to erase this. I think we'll leave it there. All right, I know I'm going pretty quick. So does anybody have any questions to hear? Everybody good? All right, so this problem is basically like the last one, where it doesn't really matter which setup we use. We're going to get e to the x and sine 3x no matter what. And so we're going to stick with the same setup. I'm going to do this just so if you're looking at it later, we can delineate what's going on. I'm going to set up u as cosine 3x. It turns out, we'll talk about that in a second. So it turns out we have to do it this way this time, but we get that. All right, so now when we do this, we're going to get e to the x sine 3x. That's going to carry down. And then minus 3, and then bracket the entire integration by parts formula. So we get uv. uv is e to the x cosine of 3x minus v du. But when I multiply v times du together, the coefficient is -3. So when I pull it out, I get +3 integral e to the x sine of 3x at this point. But that's all in the brackets. Is everybody clear to there? Everybody good to there? Any questions? Okay,
So,
now,
wait, I
go
have
ahead.
a question, sorry.
Sure.
But it just looks like it's gonna keep on doing like what we're doing. Like
That's
so-
exactly the right question to ask.
Okay.
So, all right, so what is she saying? You're right.
Is this-
Like,
is
we're
this-
just going to be able to do this forever. Go ahead, somebody.
Is this ever going to end?
No, not if I keep doing this. I can keep going. Everybody see that? Like, if I do it again, let's do one step here and get that -3 distributed. But what's really weird about what just happened? Like, you guys are catching on to it. That's good. Oh, whoops. E to the x. Let's make that 9 legible. So, like, we can keep going, but we're just going to rotate e to the x cosine 3x, e to the x sine 3x, and, like, that's just going to go forever is what they're saying. Does everybody see that? Okay, now we could have figured that out back here, right? And actually, we could have figured that out when we were talking to begin with, because you're always going to get e to the x no matter what, because derivative and integral of e to the x is e to the x. So we know we're going to get e to the x here every time. And then sine and cosine, we're going to get one of them every time. It's going to alternate sine, cosine, sine, cosine. So we knew that to begin with. But what has happened at this point in these last two steps that's even weirder than that? So what's these last two steps in green, something happened there that did not happen in this blue step. What's so weird about the green thing, other than the fact that it's going to keep cycling, which is true? What's even weirder about that last step? Look at the problem as a whole, and then the last step. What's so weird about that?
It multiplies by 3, like the last.
Okay. Yeah, it multiplies by 3, but there's something even weirder about this step. Not just that it multiplies by 3. You're not wrong. That's true. But there's something really weird about it.
If you keep going, shouldn't it all eventually cancel out? Like, because now it's all negative? Or...
Yeah, maybe not. Maybe not. It doesn't. It's harder to see that for sure.
Is it because
That's not quite what it is.
both times?
Say it again. I'm sorry.
Is it because it's the antiderivative of sine both of those times?
Yeah, not only both of those times. What's the problem we're trying to solve?
Oh, wait, what the heck?
Does everybody see this? Here's the problem, right?
It
Now,
goes
what's
back
weird
to
about the
the
answer?
Original.
That is the original problem. Does everybody get that? So not only is this just cycling, this actually cycled back to the exact problem we started with. Does everybody see that? That's what's
trippy as
weird.
hell.
Yeah, that is tricky as hell. You're right. That's weird. But that didn't happen here, right? Like this is really close to the original problem, but this is the original problem. Now, it turns out we can now get an answer because of that, but we cannot get an answer until we get back to the original problem. So these ones where it's clear it's going to continue to just cycle and cycle forever, if we get back to the original problem, now we're going to do something different, but we're going to use what we've got so far. So what we have now shown, and so we're going to not scrap that, but we're going to take what we've written so far and we're going to condense it. So what we have shown is that the original problem, integral e to the x sine of 3x, that is equal to that very last line. It's equal to e to the x sine of 3x minus 3e to the x cosine of 3x minus 9 times the integral itself. Okay, so I'm taking this original integral and I'm saying, okay, that's equal to this, because that's actually what we said here, right? We said this is equal to this, equal to this, equal to this, which means this original is equal to this last line. Everybody clear that this purple line is true? Now, we are trying to figure out what this integral is. And you can't tell me, if I'm giving you this on a quiz or test or homework, if I tell you solve this integral, you cannot tell me, okay, well, it's equal to this minus 9 times itself. Okay, we can't do that. But what we can do is solve for it. So I'm going to write the next step, and I want you to figure out where I'm getting it. And don't say it yet, but I want you to look closely at what I'm writing and figure out why it's correct. Okay, and we're going to give it a minute. Everybody want to try to figure that out on your own, why that's correct. And here in just a second, I want somebody to tell me why it's correct. Okay, so what did I do?
You added 10 of like.
I added
9.
I added 9 of them to both sides. Does everybody see that? So because this was minus times the 9 of this integral, because it was minus 9 of this integral, I did plus 9 times this integral to both sides. Well, this is 1 times that integral. So that gets me 10 over here, and it cancels over here. Is everybody clear where that comes from? If not, please ask in the chat or unmute yourself and let's figure it out. Is everybody clear where I'm getting 10? It's not always 10. It is here. We good? Okay. What if instead of minus 9, what if this had been plus 5 on a different problem? What would we have over here?
Minus 4.
Negative 4. Is everybody clear why? You would subtract 5 from both sides, and this is a 1. You guys get it? What if instead of plus 5, what if it was plus 2/3? Then what would go over here?
Negative 1/3.
Close, not quite. Because it'd be like 1 minus 2/3. You're good. Positive 1/3. Does that make sense? Everybody clear? Okay, so you add or subtract whatever this is to both sides to try to solve for it. Now, that means then the original integral, which is what we're trying to solve for, is equal to 1/10 e to the x sine of 3x minus 3/10 e to the x cosine of 3x plus a constant. And that's the answer. Really weird, but does everybody follow what we're doing there? Questions? Can be in the chat, can unmute yourself, but please ask if we're not sure on something.
So
Go ahead.
Actually, never mind. Never mind.
You sure? Okay.
Yeah, never mind.
Okay. Other questions?
So will there ever be like a test question where like it makes us go a lot of times to like get the original one back into the equation, or
No. So like this is one form that does this a lot. So like if you have an exponential like e to the x or e to the 2x, the reason this happened the way it did is because the derivative and integral of this stays the same. So no matter what, you're going to get e to the x over here. If it was e to the 5x, you'd have e to the 5x over here. Like the coefficient would be nastier, but like you'd have e to the 5x every time. Does that make sense? And then like sine alternates sine, cosine, sine, cosine. So that's why it took 2 iterations, because this stayed the same. And after doing this twice, you get back to cosine. It's also why the setup doesn't matter. It doesn't matter which one is u and which one is dv. It's just if we had let this one be dv, we would have gotten 1/3 every time, which would have made this like nastier fractions, but you would end up with the same answer. In general, could we find an example where it cycles more than twice? Probably. Will we make you do that on an exam? No. Okay. Long answer to your question, but does that make sense? All right. Other questions? Okay. One comment is that once you decide, so if you're doing this form of a problem, when you decide this setup, u and dv, you can reverse that. This u could be e to the x and dv could be sine of 3x dx, but you need to keep it the same when you do the next iteration. So if we had flipped this, if u had been e to the x when u up here was sine, then you would get down to an answer where you get 0 equals 0, which is true, but does not help you get an answer. Does that make sense? So like if you pick u as the trig function here, u still needs to be the trig function here. Whatever you go with in the beginning, you need to continue with that. Okay, other questions? Okay. Okay. I want to look at a few problems. I'm going to put several on the screen. And what I want you to decide, I don't want to work these completely, but I want you to decide what method you would use. So is this a basic form? Is it u sub? Or would you use parts? And then, so have an idea of how you'd solve it, but maybe don't solve it completely. But I'm going to put several up, and I want you to figure out what the strategy would be to evaluate these intervals. So if I've got, oops. Okay, so I'm going to give you a minute and see if you can come up with what we do on those. All right, and I added some more. Sorry. Okay, so I'm going to let you guys tell me on these. And you can type it in the chat or you can say it out loud. What do we think on the first one? Would we use U sub? Would we use parts? Is it too hard? Is it a basic form? What do you think?
U sub.
U sub, yeah. So this would be a basic U sub where U is equal to X squared. Everybody get that? Okay, and then how about the second one?
Parts.
Parts, good. And so parts where you're going to end up having to do it twice. If you go through U equals X squared and you do that setup twice, cosine is going to cycle sine, cosine, sine, cosine. But doing it twice, X squared will drop from X squared to X, and then it'll just drop off. On the next one, what would we do?
U sub.
U sub. So U would equal X cubed. Everybody clear on those three? Okay, if I have X e to the 2X, what should be done there?
Parts.
Parts, good. U would equal X, dV would equal e to the 2X. Does that make sense? Okay, on the next one, what would we do, or could we not do it?
U sub.
U sub, U would equal X squared. Okay, how about tangent versus inverse tangent? So what do you do for tangent? It's not a basic form. So what do you do for tangent?
That would be U sub, right?
Yeah.
You switch it to sine over cosine.
Yeah, you switch it to sine over cosine, and then it's U sub. So you make it sine X over cosine X dx, and I'm squeezing that in, and then U equals cosine. Now, real important, this is not a -1 power, which I think we all know if we think about it right now. But remember, this is inverse tangent, not a -1 power. So you cannot make that cosine over sine. We did just do this problem. This is parts, where you let U equal the whole thing except for dx, and dv is equal to dx. Does that make sense? Everybody good? Okay, how about sine x versus inverse sine x? So sine x,
Basic form.
basic form, yep. So integral of sine x is negative cosine x, and then inverse sine
It's basic.
is parts, yeah, where you do it basically like inverse tangent, and you guys will try that on the homework. And then, okay, what about log x over x versus x times log x? Any ideas?
Log x over x is U sub.
Yeah, log x over x is U sub. What would U equal on log x over x, yes?
ln of x.
U would equal ln of x, and du would equal 1 over x dx, which is sitting in the bottom. And now what about x natural log x? You guys think?
At parts.
That's parts. And on that one, you let U equal log x and let dv equal x dx. Does that make sense to everybody? Okay, so there are not definite rules for when you use parts and when you use U sub or when you do something else. There's not like a way to know for sure. It's good to look at problems that look similar and kind of think of different ways to do them. But U sub's often an option for problems where we don't know how to start. So if we look at that and we don't know how to start it, it's worth trying parts and see if it works out. It does work for like inverse sine. It would work for inverse cosine, inverse tangent, all the inverse trig functions will work that way. Natural log x also works that way. But like tangent probably doesn't work well with parts. You can try it and see, but it definitely works with U sub if you do it this way. There is overlap, so there may be some problems where you could do them both ways. Just because we're saying U sub doesn't mean you couldn't work it out using parts. I think this one probably not, but some problems you might be able to do both. There are problems you cannot do. So like if I put the integral of e to the x squared here, this one is impossible. So you cannot do it using stuff that we have learned. And so there's something called an elementary function. Elementary functions, those don't mean easy functions. Those mean basically any function we've ever studied. So trig, inverse trig, exponentials, logs, polynomials, every easy function, every hard function, and all of the combinations of those. So like if you plug them into each other, anything basically we've ever written in math, None of those work for e to the x squared. We'll do it with what's called a series later, but the answer will look nothing like the answers that we've gotten on integrals so far. So that is one we can prove you cannot do using any technique at all. We use a series to integrate that. So small changes to these might make them a different method or might make it completely impossible. That makes it difficult to know for sure what to do. Practice definitely helps with that, but it doesn't mean, okay, all of a sudden I'm going to know what to do every single time. You have to be willing to try something, and then if it doesn't work, go back and try something else. The next homework assignment is called Integration by Parts 2. It's not up yet. It will be up within the hour. I need to rearrange some of the problems, and I had a meeting that I didn't know I was going to have this morning. So Integration by Parts 2, I'm going to go right after this and adjust it slightly, and it'll be posted, let's say, should be up by 3 o'clock. But I will get that posted. And that one, it'll be due technically next Monday because we're trying to keep everything open for a week or for the whole week. But try to do it before tomorrow's lecture. We're going to go into a few problems where it's real tough. Not real tough, but real creative as far as how you do the problem. So some tricky problems tomorrow, and then we're going to move on to something else. Okay, I think that's it for today. If you have questions, stick around. If not, I will see you guys tomorrow. Thanks for coming.